Hello everyone. In this video, we will be discussing about how to convert any given complex circuit into a Thevenin circuit. So, this is again part of basic circuit analysis lab for the second semester students of ECE. So, Thevenin's theorem. First of all, let us try to understand the Thevenin's theorem definition. Then we will try to solve one problem so that you can solve the remaining circuits which are allotted to you in the laboratory. Okay. The Thevenin circuit states that Thevenin circuit uh, theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source in series with a resistor, and we will call them as VTH and then RTH, right? So I'll just show you here. You can see here we have a complex linear and two terminal circuit which is having two terminals A and B, and we have some load resistance RL, right? Now this complete complex circuit can be replaced by a simple circuit of a voltage source in series with a resistance R, right? And this voltage source is called as a Thevenin's voltage, and then the voltage equivalent is nothing but a voltage equivalent, nothing but a Thevenin's equivalent, and the resistance is nothing but R Thevenin's, we call it as, right? So why do we need this? In general, in a very given circuit, what happens is sometimes a few elements are variable, just like a load resistance, let's say RL. The load resistance RL may be variable, right? All the non-variable elements of a given circuit always can be replaced by this voltage source in series with the resistance RTH. That is very important, right? So load means you may connect a load means a mobile phone, you may connect a TV, whatever. So load is always generally varying. So to a variable load, all the time you need not calculate the voltages and currents which are flowing through this. Now for that we will replace the entire circuit by a voltage source in series with the R Thevenins. Okay, that is very important concept. Now you can see here. So how to find out the voltage V Thevenins? V Thevenins has to be find out by open circuiting the terminals where we want to find out the voltage equivalent, the Thevenin's equivalent. And then how to find out R Thevenin's is? R Thevenin's is again is the resistance at this terminals. And now what we will try to do is we'll try to do all the independent sources has to be set to 0. Means, so what do you mean by that? So let's say we are trying to replace all independent sources. Means if let's say we have a voltage source, voltage source has to be, tell me, voltage sources has to be what? Shall be short circuit or open circuit? Always remember, voltage sources has to be short circuited. Okay, and current sources has to be replaced by a open circuit. This you have to remember while solving any given problem. Okay, now let's consider one circuit. You can see here. So he's trying to find out, he's asking us to find out, determine the Thevenin's equivalent of a given network. You can see here, he did not give the value of the resistance RL, and assume that this resistance RL is a variable resistance, which is a variable resistance. Now, to find out this, what we have to do, sir? We have to find out the open circuit voltage across these two terminals. Let's say this is going to be A and this is going to be B. Now we have to find out the voltage across these two terminals. Okay. Now how to find out this? So very simple. Now when we are open circuiting this, the current flowing through this 7 ohms will be 0. Yes or no? Because I'll try to draw this again here. So before going to that, let's try to observe what are the steps need to be followed to find out the Thevenin's equivalent, right? So the first step is open the two terminals, remove any load between which you want to find the Thevenin's equivalent. It means, so we have to just remove this load resistance RL and try to replace this by an open circuit. Then determine the VThevenins across the two open terminals and determine the RThevenins between the two open terminals with all sources replaced with their internal resistances. So in general, we assume that there are ideal sources which doesn't have any internal source. For our practical purposes, we'll discuss different, but for all theoretical purpose, we think that they are the internal resistance is going to be 0. Now, first step is to calculate the VThevenins. So how to calculate VThevenins? Remove the component of the interest, normally called the load resistance RL. Mark the terminals as VTH, where the load was removed from. The calculate Thevenin's equivalent VThevenins by finding the open circuit voltage across the load terminals. So now for the given circuit, now I'll try to redraw the circuit which we are discussing here. So the circuit, I think we have a 12 volt source, and then we have a resistor here, and another resistor is here, and we have a resistor here, and I'm just trying to open circuit these two terminals where I have to find out, and I'm naming it as AB, and here is what I have to calculate the Thevenin's equivalent. So when I'm open circuiting this, whatever the resistor here, it doesn't matter for us, because so this is the current flowing through this is going to be 0 because it is open circuited. Yes or no? Okay, whenever this is open circuited, no current flows here, so we are not much bothered about this. So if you want to find out the Thevenin's voltage here, it is enough to find out the voltage across this. I think it is given as a 3 ohms and then a 6 ohms, right? So simply apply KVL and find out what is the current flowing through this. If you can able to find out the current flowing through this, it is very easy for us to calculate what is the voltage drop across this, and that voltage drop across this Thevenin's voltage is nothing but a voltage across this 6 ohms resistor, right? So you know how to calculate this. So simply apply KVL. If you apply KVL, as we discussed in the classroom, it's going to be minus 12 volts plus I into 3 ohms plus I into 6 ohms is going to be 0. So I can write 9I is going to be 12. So I is going to be simply 12 by 9 amperes. So if it is 12 by 9 amperes, so then what is going to be the V6 ohms is going to be simply 12 by 9 into 6 ohms. So 6 ohms, I think, but now which is very simple. You can do that 3 fours and then 3 ones and then 3 twos. Yeah, okay. So voltage across this 6 ohms is going to be simply 8 volts. So VThevenin's is going to be 8 volts. Did you get the point? So this is how we have to calculate. So we are not worried about what is the source, but remember we are much worried about this Thevenin's equivalent. Now this is how we have to find out Thevenin's equivalent voltage, right? Then, so this is the biggest circuit which you have to calculate. That I'll come back to it later, but now let's try to see first of all how to calculate RThevenins. So simply how to calculate the RThevenins is, now in this case, to calculate RThevenins, you have to remove all the voltage sources has to be replaced by a short circuit, just now I told you, and all the current sources has to be open circuited. Okay, voltage source has to be short circuited and current source has to be open circuited. Now and then just simply try to find out the load resistance in between these two terminals, okay, and then draw the equivalent. Now the circuit which we have, again I'll try to draw the same circuit which we have. Okay, this is going to be plus and then minus 12 volts which we have, and then we have some resistance here, another resistor here. Of course we have another resistor here which is very, very important. And now my job is to find out what is the the R Thevenins by looking into these terminals A and B. So for that, as you think, this is going to be 3 ohms, this is going to be 6 ohms, and then this is going to be how much? I think 7 ohms. Let's just go back. Let's check. Yeah, it's going to be 7 ohms. Now this is going to be R Thevenins. To find out R Thevenins, we have to replace this 12 ohms, 12 volts voltage source by a short circuit. By a short circuit. If it is a current source, you have to be replaced by an open circuit. Now I'll just try to replace this by a short circuit. Then what you are going to get is going to be a short circuit like this. Then I have a 3 ohms resistor and then a 6 ohms resistor. Then a 7 ohms resistor is here. It's going to be 3 ohms resistor, 6 ohms resistor, and then now I have to simply find out what is the Thevenin's equivalent here. So for that case, now you can see here this 3 ohms resistor and then 6 ohms resistor are in parallel. They are in parallel. You can just see here, are they parallel or not? Yes, both of them are in parallel. Both of them are in parallel. So if 3 ohms and 6 ohms are resistors are in parallel, obviously we will get some equivalent resistance or equivalent, and then we will be having this 7 ohms resistor which is in series. So if you find out what is the equivalent resistance, this is equivalent resistance is nothing but 3 ohms in parallel with 6. So what is 3 ohms in parallel with 6 ohms, sir? Very simply, R equivalent is going to be 3 into 6 by 3 plus 6 is 9. So 3 ones and 3 threes are 3 threes and then 2. So R equivalent is simply equivalent to 2 ohms. Okay. Now the R Thevenin's is nothing but I'll draw this here so that it will be easy for you. This is going to be 2 ohms in series with the 7 ohms. So obviously when they are in series, we have to add them. So this is going to be 9 ohms. 9 ohms. So we got VTH as 8 volts and RTH as a 9 ohms. So the total, the Thevenin's equivalent circuit, what we are looking for is a Thevenin's equivalent circuit is going to be now simply a 8 volts voltage source, 8 volts voltage source in series with 9 ohms resistance, 9 ohms resistance. So this is what a V Thevenin's and then R Thevenin's. So this is actually, and then of course we have the load resistance RL. So which is a variable resistance. So this is how you have to find out a Thevenin's equivalent for any given circuit. You can go back and see. For example, we have a circuit like this, so which is given to you. So now here across this resistance RL considered as a load resistance RL. Now your job is to find out. Your job is to find out what is the Thevenin's equivalent across these two terminals. Across these two terminals. Now you can see here. So this combination of while finding out the V Thevenin's, these two resistors doesn't make any difference because I'm just trying to open circuit here. If I am open circuiting this 220 ohms, then the current flowing through this 2.2k and 1.5k doesn't make any difference, so it's going to be 0. So simply it is better to find out what is the voltage equivalent between these two terminals. So for that case, you can see, simplify this. These two resistors are in parallel, and then find out the resultant one. Here these two resistors are in series. Then so this is going to be again a resistor. The resultant resistance of 6.8k and 220 ohms is in parallel with 5.6k. Now after you finding out this resultant resistance of this 1.5k in parallel with 2.2k, the 4.7k is in series now. Or so you need to just find out the resultant one. Just find out the resultant one, then you can get what is a VTH and RTH. Okay, so that is what you have to do it. That is what you have to do it. Is the point clear? Okay, this is all about Thevenin's theorem. Just try to find out the V Thevenins and R Thevenins. Now the next comes another important theorem, that is maximum power transfer theorem. So the maximum power transfer, if you are okay with Thevenin's theorem, if you are able to find out the Thevenin's equivalent, it is very easy for you to understand this maximum power transfer theorem. So what maximum power transfer theorem states that the maximum power is transferred to the load and the load resistance is equal to Thevenin's resistance as seen from the load. It means, so just now we have calculated, so what is the Thevenin's equivalent R Thevenin's, right? So whenever this R Thevenin's is equal to the R load resistance RL, whenever this RL is equal to R Thevenin's, then there is a maximum transfer of power from the source to the load. Okay, so example, let's say we have got this 9 ohms, right? Whenever this load resistance is 9 ohms, then only maximum power transfer will happen. If it is below 9 ohms, let's say 7 ohms or 6 ohms or 2 ohms, or above 9 ohms, that is 10 ohms, 12 ohms, whatever, 13 ohms or 100 ohms, whatever. But in this places, there is no maximum power transfer, right? So if you want to see it graphically, you can see here. So if we have a resistance R, Thevenin's resistance, there only the maximum power transfer will happen. There only the maximum power transfer will happen. So what will you do? Whatever for the circuit which you have given, the circuit which we have given to you, your job is to just find out R Thevenin's. Anyway, you will find out the R Thevenin's. Now in the laboratory, what you are going to do is simply vary the load resistance RL from 0 to some value. So at one point of time, the power will be maximum. That is, your power will be maximum whenever there is the resistance R, right? The resistance will be very high. So simply you can calculate the value of the power using the formula. You know that power is equal to P is equal to V square by R. P is equal to V square by R. This is very, very important, right? Or I square R also you can do it, but generally we will note down the voltage across the two terminals, voltage across the Thevenin's resistance or the load resistance RL. So your job is to just find out. So how to find out the what is the formula? The P maximum is generally is nothing but, so V Thevenin's square by 4 into R Thevenin's. The maximum power is achieved at this point, right? So if you change the value of R Thevenin's, then there will be a difference. So this is what you have to do in the laboratory. So if you are okay with the Thevenin's theorem, it is very easy for you to do it. You can see here the resultant which just discussed is 8 volts in series with 9 ohms. So the load resistance RL has to be 9 ohms to get the maximum power transfer. So in the laboratory, so whatever to the circuit which is allotted to you, you have to just find out in the write down a table where you will be varying the load resistance values from 0 to whatever. Let's say if your R Thevenin's is 1K, example I'm telling you, 1 kilo ohm, you can start from 0 to 0, then 100 ohms, then 200 ohms, 500 ohms, then you will be having 1 kilo ohm, then 2K, 3K, 5K. So at 1 kilo ohm, you will get the maximum power. You will get the maximum power. That to calculate the maximum power transfer is going to be P maximum is going to be V Thevenin square by 4 into R Thevenin's. Okay, 4 into R Thevenin's. So this is what you have to do it. This is what you have to do it. Okay. Thank you.